Okay, so welcome members. Today now we are going to see how we handle a bucket. If you are given a bucket, how can you get the volume of that bucket? And also, how can you calculate its height? But here, most likely, we are going to use similarity. Okay, but please don't forget to subscribe to the channel. Now, the diagram below shows a bucket made out of the lower part of the cone. So this is the bucket, this is the height, this is the slanting side of the bucket. Calculate the height of the bucket, the volume of the bucket, and then they are telling us to get the cone, the volume of the cone that was cut off. Now, when they give you that, you start by extrapolating that cone so that you will be having what would have been the original cone. Now, you extrapolate this side there. So you put there your ruler, then you try to extrapolate that side there. And also the same thing, you put here your ruler, and then you extrapolate this line here. So this means that this was my original cone. This was now my bucket. So if that was my bucket, it means that now the height of that cone was from there up here, up this lower side. So now remember that after me extrapolating, now I'm going to be forming a right angle triangle, this one. I think now you see if I pull out this right angle triangle and I try to put it here, you see that I'm going to be having such a thing. I think you see if I pull out this triangle there. So start, if I pull out this triangle O, A, B, that's what I have. So start, this one is 28, 12 centimeters, and this one is 20 centimeters. So now there, so they want me to get this height here, which was given the question this height. Now there, members, we are going to simulate. How do we simulate? You see, if I call this one, if this is A, I call this M, and I call this one B. So now, this triangle BMB is similar to triangle B or A. So now, if I use similarity, I need to be having this, let me call this length BBL. So that if I have the whole of this here, it's going to be now L plus 20 up the side down. Now, so if I have in these two triangles, I have the radius, I have the radius. Then here, I have the slanting side of the small rectangle, triangle, and then the slanting side of the big triangle. What does it mean? It means that I can use now similarity to get the value of L. If I get the value of L now, I'll be able to get this height, and if I get this height, I'll be able to get the height I want. So now here I said, using similarity. What does similarity say? I'm going to say that big radius, we compare with similarity if two figures are similar. So I'm going to say big radius over the big slanting side. Big slanting will be equal to, if something with radius, then here you put small radius over the small slanting side. Slanting side. Now, you see that now this is similar, this one. Now, my big radius is going to be 28 over my my big slanting, which is L plus 20. It's going to be my small radius for this triangle here, which is 12 over the small of the slanting of the small triangle, which is L. And that's how we use similarity. Now allow me to cross multiply here. This is going to be 28L equal to this times this, 12L, then plus this times this, 240. So that now when I bring this beside, I have 16L equal to 240 divided by 16, so that your L is going to be 15 centimeters. Now if I have L as 15, It means that now I'm going to draw that diagram. If I did draw that diagram, look at what I'll be having here. Now it's that this is my B, this is my O, this is my A, this is my B. I have now my L as 15, I have this as 20, this is 28, this is 12 centimeters. Now this is the height I want. Now, it's that if I call this height H, this is in my M, if I call this height H, so that I can get this height, the mid height, then minus this small height to get this, because I know that this big slanting side here is this past this, which is that 5, the whole of this. Meaning that now there I'm going to just use Pythagoras. So now I say, using Pythagoras theorem, Pythagoras theorem there. Now which triangle are we going to start with? Let us start with V O A. Triangle V O A. So now V O squared, then plus now this 28 squared, I'll get that 5 the whole square. And now my V O is going to be the square root of that 5 squared, then minus, when I take this side, 28 squared, then I get a square root there. And so now my VO here is going to be, that one we get 35. So it's that we get 21 centimeters. Now, if I know the length, this is the VO, I know that now the length of the full corner, I know it. Now I want now to get this small height here. Now I'm going to use VMB. If I use now VMB, this one's now my height squared, now plus 12 squared, it's going to give me 15 squared using this VMB. So my h is going to be 15 squared minus 12 squared, then I get the square root there. So it's that my h here. It's going to give me 9 centimeters. So if I have this h and I have this, so that I roll up now h plus this, so that h plus h is equal to VO from here. This VO is equal to h plus h. Now, my h is going to be VO, which is 21 minus 9. So now my h is 12 centimeters. So if I have my height there, now I've got the height of my bucket. Now let us get also, the one has to get the volume of the box. So if I allow me to use this part here, now my part B, the volume, you know that our B, of now the volume of this bucket is given by a third by the height of that, the big radius times the small, then plus the small radius squared. So from here, it's like from here my big R, the big radius is 28, then my small r is 12. Putting them here, I have a third times, now it's the radians by 1.4 into now 28 squared, then plus 12 times 28, then plus 12 squared. And now putting this on your calculator, you have then times this height, I'm forgetting the height, 12. So that I'm getting 15,875.84 centimeters cubed. That's the volume of that first one. Now, I also come and get now part C, the volume of the part of the cone which was cut off. Now, the cone that was cut off, is this one. So if I am to draw it, I'm going to draw that on here. Draw that on. You see that's the on. So that its radius was 12. So this is 12 centimeters. And so that its height was the height we got here, which is h. Our h was 9 centimeters. This is b, m, b. Now you know that volume is over on is a third by r squared h. Our volume is going to be a third times 3.14. Now times the radius, which is 12 squared, then times the height, which is 9. Putting that on the calculator, you have 12. So here I have 1356.48 cubic centimeters, and so that's how we get that members. So that's how you go through this question members. I wish you the best.